All right. We are doing grade 8 mathematics, and the topic is numbers. And what we are going to be looking at in this presentation, we are going to identify odd numbers. We are going to identify even numbers, prime numbers, multiples, factors, squares, and cubes in natural numbers. All right. Now we will also arrange directed numbers in order of size. We will also write directed numbers on vertical and horizontal number lines. All right? Yes. Now let's see what we have. We have odd numbers. Okay, let me start with natural numbers, all right, so that we can take these numbers from here. Natural numbers, all right. So when we talk of natural numbers, we are actually talking about counting numbers, all right. So we can say we have a set of natural numbers would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. That means our set here is infinite. It has no ending. All right. Now, from this set, we can take out other sets. Like when we were doing sets, we talked of a universal set, which is a set that contains the other sets. So that means we form the other set from the universal set. So in terms of the odd numbers, all right, odd numbers, odd odd numbers, all right. What do? We can uh, take these odd numbers from this set, all right. So odd numbers would be what? When you talk of odd numbers, we are talking of numbers which are not divisible by 2, okay? So we can take 1, we can take 3, all right? All right, 5, 7, we can take 9, okay? We can take 11, right? And many others, all right? These are odd numbers, okay? So, when you divide them by 2, they will always leave a remainder of 1, okay? Now, what else? We have even numbers. Even numbers. So these even numbers now are numbers. Let's take them from here. We have 2, all right, 4, 6, 8, 10, and so on. Okay. Now these numbers are divisible by 2, and when you divide them by 2, they leave a remainder of 0. Okay. They leave a remainder of 0 when divided by 2. All right. Okay. So now we have prime numbers. Prime numbers. All right. So when we talk of prime numbers, we are talking about numbers like 2, all right, 3, all right, 5, okay, 7, 9, no, not 9, 11, okay, and so on. Now, you would think that when you start with 2, you would think that prime numbers are even numbers, but nope, they are not, because now you have some odd numbers here. All right. Now, if we said, oh, it's a combination of even numbers and odd numbers, said nope. Why? Because you are aware that somewhere here between 7 and 11 we had to leave 9. Why did we leave 9 here? It's because prime numbers are divisible by 1 and themselves. So a prime number is a number that is divisible by 1 and itself. That means it has only two factors, all right? 1 and itself. Look at this. 2 is divisible by 1, the remainder is 0. And 2 is divisible by itself by 2, and the remainder is 0. 3 is divisible by 1 and 3. 5 is divisible by 1 and 5. 7 is divisible by 1 and 7. So if you had taken 9, 9 is divisible by 1, by 3, and by 9. So it has 3 factors. So it is not a prime number, all right? So 11 is divisible by 1 in itself. So prime numbers are numbers that are divisible by 1 and themselves only, all right? Only, all right. Now, let's look at um, here we will say, okay, right, we have looked at the main types of numbers, all right? So we can as well go to squares. I just want us to look at square numbers. Square numbers, all right? The square numbers. The square numbers are 1, 4, 9, all right, and so on. Okay, so how do you get a square number? You just take a natural number and square it. A natural number and square it. A natural number and square it. So what do we do? When we talk of 1 squared, remember is 1 times 1. Okay, so that becomes 1. Okay, 2 times 2. All right, 2 squared is 2 times 2, which becomes 4. All right, then 3 squared is actually 3 times 3, which becomes 9. Okay, so now you need to understand that this these values here, 1, 4, 9, are called square numbers, like we have just indicated here. All right. Okay. Now that is beautiful. We have cubic numbers. Cubic numbers are 1, okay, 8, all right, and so on. Let me show you why. I'm just stopping at 8 because I wanted us to be within this. But we can go on. Let's go on because our set is infinite. Okay. All right. Let me just do this. Let me just do this right here. All right. Let me just do this right here. Okay. Thank you, Father. Thank you. Okay. Now, this is it. Now, this is it. We managed to okay, we can talk of uh, I think we have 27 here, all right, and then we have 64 here, and so on. All right, let's see how we get to the cubic numbers. So you just take a natural number and you cube it, a natural number and you cube it, a natural number and you cube it. So this gives us what? 1 cube is 1 times 1 times 1. Okay, so that becomes 1. All right, so 1 is a cubic number. Here 2 cubed is 2 times 2 times 2. All right, 2 times 2 is 4. Times 2 is 8. So 8 is a cubic number. 3 cubed is 3 times 3 times 3. All right. So 3 times 3 times 3 it's basically um 3 times 3 times 3, it's basically 3 times 3 is 9, times 3 is 27. All right. You see? So you can just look at 4 cubed on your own. What do you get? You will tell me what you get here. Just do it, okay? Now, this 1, 8, 27 now are cubic numbers. All right. We are even, okay? We are even. Now, let's continue now. There are what other types of numbers which we will look at. These are multiples. Multiples. All right. What are multiples? Okay. When we talk of multiples, like from the word multiple, which comes from multiply, okay? Now, we will still be looking at the natural numbers, okay? Natural numbers. So, if we talk of multiples of 2, all right? Let's say we are talking about multiples of 2. All right, let me do this. Multiples of 2. Yeah, multiples of 2. Multiples of 2. For instance, okay? When we are looking at the multiples of 2, what we do, we will still take natural numbers 1, 2, 3, 4, okay? And so on. Then we multiply them by 2, always by 2, always by 2, okay? By 2. What do we mean? It's because we are saying multiples of 2. So we take the natural numbers and multiply each natural number by 2 and see what we are going to get. We would get what here? 2. What about here? 4. What about here? 6. And 8 here. All right. We would continue. So these 2, 4, 6, 8 are multiples of 2. Let's say we wanted to find multiples of 3. Multiples of 3. Multiples of 3. Okay. How would you do it? We take natural numbers. Then we multiply them by what? By what? By 3, because we are looking at multiples of 3. Okay. What do we get here? 1 times 3 is 3. Okay. 2 times 3 is 6. All right. 3 times 3 is what? 9. All right. 4 times 3 is what? 12. So these are the multiples of what? Multiples of 3. Now, sometimes we we use this simple. We've seen it in some textbooks. They would just use this. They would say uh, multiples, capital M and suffix 2. When they say multiples of 2, then that means that set would be 2, 4, 6, 8, and so on. All right. Then multiples of 3. What would you do? M suffix 3. Then you would have a set of 3, 6, 9, 12, and so on. All right. That's when we are talking about multiples. All right. Now, what about factors? Hmm? What about factors? What about factors? All right. Now, when we talk of factors, all right, we are talking about let me give you. We are talking about numbers that actually divide a number and leave a remainder of 0. Let's talk about, let's say we want to find factors of 6, all right? let's say we want to find factors of 6. I will get to you. Factors of 6. Let's say we want to find factors of 6. All right. What would we do? Factors of 6, we just look at the numbers which, when you divide 6 by which, when dividing 6, you get a remainder of 0. 6 divided by 1, what is it? It's 6. Okay? 6 divided by 2, what is it? It's 3. The remainder is 0. Okay? All right? 6 divided by 3 is equal to what? 2. And the remainder is what? 0. Okay? What else? 6 divided by 6, what do you get? 1. And the remainder is what? Is 0. Okay? Now, these numbers, these ones, are factors of 6. Okay? So that means if we would say, we would use this symbol, we would actually say um, uh, factors of 6, f suffix 6, we would have what? We would have 1, 2, okay, 3, 6. These are the factors of 6. Okay? Let's say we want to find, sometimes you may look at it like this. You say, okay, when I multiply 1 by 6, I get 6. When I multiply 2 by 3, I get 6. So 1, 2, 3, 6 are factors of 6. All right. Okay. But the basic definition is this one. Now, let's say we wanted to find the factors of 12. Okay? What do you do? Okay, let's come here. Factors of 12. What do we do? We would say, all right, we would just say um now we would say, okay, 12 divided by 1, that is 12, no remainder. 12, okay, divided by 2, that is what? 6, no remainder. 12 divided by 3, that is 4, no remainder. Okay? Now, 12 divided by 4 is 3, no remainder. Okay? 12 divided by 5, no. 12 divided by 6, yes, 2, no remainder. Okay? Then 12 divided by 12, what do we have? 1 and no remainder. So these numbers, these ones, all these are the factors of 12. Because when you divide 12 by them, the remainder is 0. So factors of 12 would be what? 1, okay, 2, 3, 4, 4, all right, 6, and 12. Okay? All right, this is it. Now, we looked at types of numbers, and we looked at natural numbers, odd numbers, even numbers, prime numbers, square numbers, cubic numbers, multiples, factors. So now in our next presentation, we will continue with directed numbers. I know I mentioned them in our objectives, but um, time is the limiting factor. We will continue in our next presentation. Take care.